Assalamu alaikum. I am Mohammad Tasbir Kuri, Milestone College from Mohammadpur branch. Hope you are fine. So today we are going to start a new chapter, chapter 12, simple simultaneous equation of two variables. Just today we are just going to discuss about exercise 12.1. So before we just going to start, here is a just the definition. You can see here in the here simple simultaneous equation. So what is that? Simple simultaneous equation means two simple equations in two variables when they are presented together and the two variables are the same characteristics. Such two equations together are also called system of simple equations. So in class 8 we discuss about this simple simultaneous equation. So we will just discuss here more about this equation. So here you can see in the board here I am just writing here an equation 2x plus y equal to 12. So if I put the value of x equal to 5 and if I just put here the value of y equal to 2, then you will see that 5 into 2, that is 10, and for value of y 2, so left hand side it will be what? 5 into 2 plus 2, that equal to 10, 12. And similarly on the right hand side you will see the right hand side is here 12. Similarly if I just put here the value of x is 0 and the value of y is 12, then you will see that is 2 into 0 plus 12, that equal to 12, whereas your right hand side is also 12. So similarly if I just put here 3 in the place of x, I just put here 3, and if I just put here the value of y equal to 6, then you will see that is 2 into 3 plus 6, that equal to 12. So in right hand side that is 12. So for this you can go more values, you will get more values, and for those value of x and y you will get the left hand side and the right hand side are equal. Similarly if I just for the second equation, that is x minus y, you can see there in the board is written x minus y. If I just put here the value x equal to 0 and the value of y equal to minus 3, then you will see 0 minus 3, and that is 3, positive 3, whereas your right hand side is also 3. Okay. Similarly if I just put here that is x, the value of x equal to 5 and value of y equal to 2, you will see that it will be 5 minus 2 and it is 3, whereas your right hand side is also 3. So like that, if I just use another value, that is the value of x equal to 3 and value of y equal to 0, then you will see that 3 minus 0 equal to 3, where your right hand side is same 3. So you will see for this value 0 comma minus 3, 5 comma 2 and 3 comma 0, for all of them this equation is just solved. Okay. And similarly for this 5 comma 2, 0 comma 12, 3 comma 6, for all those values this equation is also proved. But you can see for the both equation, if you just look at them, you will get 5 comma 2 is common. So for these two equations there is a common solution, that is 5 comma 2. So in that we can say if the two equations discussed above the considered together a system, both of the equations will be satisfied simultaneously only by 5 comma 2. So both of the equations will not be satisfied simultaneously by any other values. So the system of equations have solution, that is 5 comma 2. So I think you understand. Now I am just going to for this such type of system of equation, and there have some comfortability for the solution of the simple supplementary equation in two variables we are just going to discuss. So you can see here, now we are going to discuss about the comfortability for the solution of simple simultaneous equation in two variables. So here the two equations you can see here, and you can see they have solution of one solution before we just discussed. So we will say this type of equation where only one solution is there. Such system of equations are called consistent. So what we are going to say? The system of equation has unique solution. That system of equation are called consistent. So we will call this type of equation as consistent, where only one solution. What is the solution? 5, 2 is there. Only one solution is there. So we will call this system of equation is consistent. Okay. Comparing the coefficient of x and y of the two equations, any equations of the system of equation cannot be expressed in terms of the others. That is why such system of equations are called mutually independent. So what is it going? If we multiply with this equation with any number, we will not going to just express this one. So for this type of equation, these are called mutually independent. Independent means they are not dependent. For this equation, if you multiply the second equation by 2, you will get here 2x, here will be 2y, it will be 6. So you will not get the first equation by multiplying, by comparing, or by dividing anything. You cannot get the first equation. So like that, we will, if such type of equations are there, we will call this type of equation, this system of equation are independent, mutually independent. Okay. So in the case of consistent and mutually independent system of equations, their ratio are not real equal. Their ratios are not equal. That means the ratio of the coefficient of x is 2 by 1. These are not equal. The coefficient of y, that is 1 by minus 1, they are not equal. So this type of equations are, the ratios are not equal. In this case, the constant terms need not to be compared. We are not going to, for when we get their variables coefficient are not equal, we will not compare their constant terms. So you can look here, number 1, here is an equation, there is another equation, a1x plus b1y equal to c1, and a2x plus b2y equal to c2. So their ratio of x term, a1 by a2 not equal to b1 by b2. Such type of equations, that is consistent, that is independent, and yes, it has one solution. It has solution, but only one solution is there. So we will just characteristics like this. When we will just compare their ratio are not equal, the coefficient of x and y's ratio are not equal, then we will call it consistent, independent, mutually independent, and has one solution, and that is for 1. Okay, this is one type of system of equation. Now we are going to discuss second type of equation. You can see, here, if both of the sides of the first equation are multiplied by any number, and we get the second equation. Again, if we both sides of the second equation divide by any number, we get the first equation. That is, the two equations are mutually dependent. Okay, so I'm just going to write another equation. If I just write 2x minus y equal to 6 and 4x minus 2y equal to 12. I am just write here two equation, the system of equation. So in this equation, the first equation, if you multiply by 2, if you multiply here by 2, the whole equation, if you multiply by 2, you will get 4x minus 2y and 12. So if you divide the second equation by 2, you get the first equation. So the thing is say to if both sides of the first equation are multiplied by any number, we get the second equation. So here you will see, if you multiply it by 2, we will get the second equation. If both sides of the second equation divided by any number, we get the first equation. If we divide it by 2, then we will get the first equation. So either way, if you see that we will get just multiplying or dividing by the first equation and you will get the second equation, you will say these two equations are mutually dependent. So in such type of equations, we will say that is mutually dependent. So if first equation has infinity number of solutions, so the second equation has also infinity number of solutions. Such equation will get that. Such system of equations are called consistent and mutually dependent. Such system of equations has infinity number of solutions. So if we compare the coefficient of x and y and the constant terms of the two equations, we get their ratio becomes equal. You can see here. So if we just do the ratio, if we just 2 by 4, that equal to minus 1 by minus 2, and that equal to 6 by 12. So all are equal to 1 by 2. So you can see their ratio, all their ratio are equal. So this type of equation, we say their ratios of, this is x, the coefficient of x, the ratio y, and the constant term, they all are equal. For those equations, we will say that is consistent, they are mutually dependent, and has infinity number of solutions. So for such type of equation, where we will get the second equation by multiplying or dividing of first equation, we will get that. Those type of equation we will call dependent. Then that has infinite number of solutions, so we will call that is consistent, and it is infinite number of solutions, and their ratio of the x and y and the constant term, they are equal. Now we are just write here two different equations. You can say here 2x plus y equal to 12 and 4x plus 2y equal to 5. So if you multiply the equation number 1 by 2, you can see if you multiply it by 2, you will see here the equation 1 is multiplying by 2 and we will get 4x plus 2y that equal to 24. So you can see the term of x and y are similar, but the constant terms are not here equal. So of the first equation, both sides are multiplied or divided by any number, and if we did not get the second equation, such system of equations are inconsistent and mutually dependent. Okay? So such system of equations have no solution. So we will say this type of equation, this systems of equation has no solution. So in case of system of equation, this system of inconsistent and mutually independent equations, ratio of their coefficients of the variable are not equal of the ratio of the constant terms. So we will say that 2 by 5, 4 equal to 1 by 2, their ratio are equal, but 12 by 5, that ratio is not equal. So we can conclude like this way. If a system of equation, their x variables coefficient are equal to y variables coefficient, but it's not equal to the ratio of the constant terms, we will call that inconsistent, and these are independent and has no solution at all. So of this, we just compare the system of equation. If the coefficient of x and the coefficient of y are not, their ratio are equal, we will call it consistent. These are independent and has solution, yes, but one solution is there. If the two equation, that is one system of equation, the coefficient of x term and the y term, their ratio are equal, and as well as it is equal with the constant term. So we will call that consistent. That is dependent, and yes, it has solution and lots of solutions. There is infinity number of solutions. But if the coefficient of x term and the y term, their ratio are equal, but the constant terms ratio is not equal, then we will call it inconsistent, independent, and has no solution at all. So this is the chart you have to memorize. Then we can go and solve the maths of this chapter. Okay, so here is exercise 12.1. So the question is told us, that is, mention with arguments whether the following simple simultaneous equations are consistent or inconsistent, mutually dependent or independent, and indicate the number of solutions. So here is number 1, the system of equation x minus y equal to 4 and x plus y equal to 10 is given here. So I am just going to solve that given system of equations is x minus y equal to 4, x plus y equal to 10. So ratio of the coefficient of x is 1 by 1, that equal to 1. So coefficient of x is what? 1, and the second equation also the coefficient is 1 here. So that equal to 1 by 1 equal to 1. So ratio of the coefficient of y is minus 1 by 1, that equal to minus 1. So you can see the coefficient, the ratio of the coefficient of x and the ratio of the coefficient of y are not equal. So we get 1 by 1 is not equal to minus 1 by 1. So we can say there, you can see here, you can see in the chart here, when the coefficient of x and y, their ratio are not equal, we'll call this system of equation is consistent, independent, and has solution, and that is one solution. So we will just going to write, therefore the system of equations, the system of equation that is consistent, mutually independent. The system of equation has only one or unique solution. So I think you understand the question of how we are going to solve the question number 1. So it just goes to write this answer: consistent, mutually independent, and there is only one solution. So I think you understand. Now we are going to solve equation second question. So here is question number 2. So question number 2 is 2x plus y that equal to 3 and 4x plus 2y that equal to 6. So solution. So for finding solution, we are just going to given system of equations is, that is 2x plus y equal to 3, 4x plus 2y that equal to 6. So ratio of the coefficient of the coefficients of x is 2 by 4, that is 2 by 4. Ratio of the coefficient of y is 1 by 2. Ratio of the coefficient of the constant terms is 3 by 6. You can see here the coefficient of first equation x is 2 and second equation coefficient of x is 4. So 2 by 4 is the ratio. Then the coefficient of y, here it is 1 and here it is 2. So the coefficient and the ratio is 1 by 2, and here it is the constant part is 3, and in the second equation you will see that is 6. So you can see it is 1 by 2, it is 1 by 2 and it is also 1 by 2. So when you will see the system of equation, the coefficient of the ratio of the coefficient of x term, y term and the constant term all are equal, we will call it consistent, dependent, and yes, it has many solutions. So we are just going to conclude like this way, that therefore, so we get 2 by 4 equal to 1 by 2 equal to 3 by 6. So therefore the system of equations is consistent and that is mutually dependent. That was in independent, but here it is dependent. So, and the system of equations has infinity number of solution. So it is the solution of number 2. I think you understand. So now we will go for the third math of today, and inshallah I think if you understand third number question, you will able to solve rest of the question of this chapter. So here is number 3. So question number 3, I'm just going to write it. So x minus y minus 4 equal to 0. 3x minus 3y minus 10 equal to 0. So I have to change the sign of the constant term. So we can write here x minus y that equal to 4, 3x minus 3y that equal to 10. Okay, so the solution here. So here is number 3, question number 3. I am just writing on the board. You can see here. So we are just going to solve it. Before we just going to solve, we have to just change the sign of the constant term. So here I am just writing x minus y that equal to 4 and 3x minus 3y that equal to 10. Now given system of equations is x minus y equal to 4, 3x minus 3y equal to 10. So the ratio of the coefficient of x is 1 by 3. Ratio of the coefficient of y is minus 1 by minus 3. Ratio of constant terms is 4 by 10. So you can see we get here 1 by 3 equal to minus 1 by 3 equal to minus 1 by minus 3, not equal to 4 by 10, right? So we can see the chart again here, the third number rules you can see here, where the ratio of the x and the coefficient of x and the ratio of the coefficient of y are equal, but the constants ratio are not equal. So such type of equation we will call inconsistent and independent and has no solution. So we are just going to end this. Therefore the system of equations is inconsistent and mutually independent. The system has no solution. So this is the math that we did today. So I think you understand the class and the homework of today's class, that is HW. You will just solve of this chapter, problem number 7, 8 and 9. This is your homework. So please do this homework, and inshallah in the next video you will see more maths about the next chapter of 12.2. Inshallah. Till then, bye bye. Assalamu alaikum.